our tutorial video.
I am Demi.
I am Anna. And I am Myrine. And for today, we are going to teach you how to solve all our problems using linear programming graphical method. Owing the importance of linear programming models in various industries, many types of algorithms have been developed over the years to solve them. Here, we are going to concentrate on one of the most basic methods to handle linear programming problem, the graphical method. In principle, this method works for almost all different types of problems, but gets more and more difficult as decision variables and constraints increases. Therefore, we'll illustrate it in the most simple way, for two variables only. So let's get started with the graphical method.
The problem we are going to solve today is a maximization problem with the objective function of x sub 1 plus 2x sub 2. The constraints are x sub 1 less than or equal to 1, x sub 2 less than or equal to 2, x sub 1 plus 2x sub 2 less than or equal to 2.
For the first constraint, we have x sub 1 less than or equal to 1. We let x sub 2 is equal to 0. So using substitution method, we have here x sub 1 is equal to 1 and x sub 2 is equal to 0. For our graph, we plotted here x sub 1, which is 1, x sub 2, 0. So we shaded the part on the left side since our constraint is x sub 1 less than or equal to 1.
For the second constraint, we have x sub 2 less than or equal to 2. So we let x1 equal to 0, and by substitution, we have x1 equal to 0 and x sub 2 equal to 2. And for the graph, we have x1 equal to 0 and x2 equals to 2. So we draw a line from x sub 2 equal to 2, and then we shaded that part below the 2 because we have the second constraint x sub 2 less than or equal to 2.
And for the third constraint, we have x sub 1 plus 2 x sub 2 less than or equal to 2. So we let x sub 1 is equal to 0. So 0 plus 2 x sub 2 less than or equal to 2. So we have 2 x sub 2 equals to 2. So we divide both sides with 2. So we have x sub 2 is equal to 1. So for x sub 2, we let it to be 0. X sub 1 plus 2 multiplied by 0 is less than or equal to 2. So we have x sub 1 is equal to 2. So with our graph, we have x sub 1 is equal to 2 and x sub 2 is equal to 1. So we plot that here in our graph. So x sub 1 is 2 and x sub 2 is equal to 1. So we have this graph. In finding our feasible region, we plotted all the points from our constraints. We have here our first constraint, second constraint, and the third constraint. In finding the feasible region, the region where all the constraints intersect, that's the optimal region.
For finding the optimal solution, we have identified the coordinates for points A, C, and D. So for point A, we have x sub 2 equal to 1, x sub 1 equal to 0, and for point C, we have x sub 1 equal to 1 and x sub 2 equal to 0. For point D, we have x sub 1 equal to 0 and x sub 2 equal to 0. And since we saw in the graph earlier that point B is the intersection of all the graphs of the constraints, we identified the lines that intersect, which are x sub 1 less than or equal to 1 and x sub 1 plus 2 x sub 2 less than or equal to 2. So by using elimination method, we find the value of x sub 2. So x sub 1 less than or equal to 1 minus x sub 1 plus 2x sub 2 less than or equal to 2 equals, so negative 2x sub 2 less than or equal to negative 1. And then we divide both sides with negative 2. So we have x sub 2 is equal to 1/2. So to find x sub 1, we let x sub 2 with a value of 1/2. So x sub 1 plus 2x sub 2 equals to 2. X sub 1 plus 2, we substituted x sub 2 with 1/2 equal to 2. So x sub 1 equals 2 minus 2 times 1/2. So we have x sub 1 equal to 1.
In finding the optimal z value, we substitute all the points to the objective function, which is x sub 1 plus 2 x sub 2. So at point A, z is equal to 0 plus 2 times 1, which is equal to 2. At point C, z is equal to 1 plus 2 times 0 and is equal to 1. At point D, z is equal to 0 plus 2 times 0 and is equal to 0. At point B, z is equal to 1 plus 2 times 1/2 and is equal to 2. So as you can see, we have two optimal solution, which is at point A and at point B. That was it for today. I'm Myrine. I'm Demi. I'm Anna.
And see you soon in our next video.
And don't forget to
Like,
subscribe.